Welcome back. This time we're gonna look at how to create shaders using Compose and Skia. Shader scripts are just strings, so we will create the minimal shader script. It needs a main method, and the main method takes the coordinates on screen in the form of a vec2 object, and it will return a half-4, which is the color of that pixel. So if we create a half-4 with the values 1, 0, 0, 1, that will be red and fully opaque. And I'm gonna add a language tag here. It's using a plugin called GLSL that gives us syntax highlighting in the script. Very useful. And now we can use our script by creating a runtime effect. We create a runtime effect for our script, and then we will try to draw it into our canvas. We fetch the native canvas and draw a paint in it. And the shader paint we will create by creating a new paint, and on that paint we will set the shader to our runtime effect. And we also have to give it some parameters. We will give it an empty byte array for the uniforms for now. And we also have to give it the children. We set it to null. And the local matrix, I will also set that to null. We don't need it right now. And we can't run it because the script is not Kotlin, so we need to put in semicolons on the end of the lines. And now when we run it, we see a shader creating a completely red paint. I will put in a clip rect. Since our canvas is only 400 times 200 pixels, I wanted to only paint that area. Next step is to give our script some parameters. Parameters are called uniforms in the shader scripts, so we'll create a function to create the data that we want to send in. The data we want to send in is the height and the width of the canvas, so we can use it inside the script. So I give it the width and the height as ints. Then we have to create a data object from the ints. So we somehow create bytes from the ints. I will use a sequence of bytes. And then convert it to a byte array. So each int we will convert to bytes, and we do that by just taking each int we'll make this a extension function on the sequence scope because we want to call yield inside of here. So now we can convert our int since an int is 4 bytes, I will repeat this 4 times, and for each byte we will shift the int 8 bits and then take that as a byte and return it or yield it into the sequence. And now we have to tell our script that there is data coming in. It's called uniform. So we create a uniform for the width and a uniform for height. And now we can use it inside our script. So if we just take our coordinate and divide it by the size of the canvas, it's the width and the height, and we use that as our red and green components of the color, we should get a nice gradient. Next, to make the shaders a bit more interesting, I want to animate them, and to animate we need time. And I will create a little function to give us an event for each frame, and it will give us the time that have passed since we started the shader or the program. So it starts at time 0, and we calculate or saves the time at the first frame, which will be the start time, and then for every frame in this infinite loop we will take what's the current time and calculate how much time have passed since our first frame. In that we will get how much time have passed since the program start, and we're gonna divide with 1 second in nanoseconds, so that is 1 divided by that's milli, micro and nanoseconds. Okay, and this needs to be a composable, and we need to import the library. I usually put a star at the runtime here, and it finds the import by itself. And now we can add it to our uniforms. It's just that time is a float, and we only support ints for our data by now, so I will change this to a number, and we will change our yield bytes so it also can take a number, and our value that we're gonna create bytes from, now it's a bit different. For ints we just take the original value, which is a number now, and for floats we will convert the float to an int but keep it as a float bitwise. Otherwise we are not supporting it for now, so just do a to do here. And we can now add our uniform as a float, which is the time, and then we can use it in our script if we, for example, just take our blue component and make it pulse as a sinus wave. Now if we try to do a preview of it, we don't see any changes because the preview can't handle animations. So we have to start the actual program, and we see animated shader, and I will change this so it fills the whole window. And we have created a shader that supports animation and knows about the size of the window. And that's all I wanted to show this time. Thank you for watching.